What I will do today is present you a checklist to help you steer a data science project. Just a quick presentation. My name is Morgane Mahaud. I have a PhD in material science. I have worked a few years as data engineer, and lately I've been data scientist at Spark. So not Apache Spark, Spark is a consulting company. We are based in Dublin and in Malaga, and we are specialized in data and more specifically bridging the gap between product and data. So what does it mean exactly? That means that we took the AI system and we put that into the product context and we make it fit the best as we can. So that is valid for the full timeline of a product, from preliminary study to maintenance, and from all level of detail of a product, from the product itself to a line of code or a data point. So what I'm trying to do today is not to tell you exactly what to do. I just want to give you a checklist to help you just not forget important stuff. Oh, there is bad formatting issue. This is quite ugly. So be it. So first, why a checklist? Well, I'm also a scuba diver in addition to be a data scientist, and I like checklists. They help me to not jump into the water with my hair off. So yeah, checklists are nice. And especially in consulting, when you jump from project to project, having processes, having checklists can help you just put some order and put some structure into the unknown. So what's the checklist exactly? So that checklist is Portland. If you don't know what that name means, it's the French name for those really cool old map, as you see one example here. So it helps sailor travel, and it will help you navigate the project. The first name in Portland is the project vision. That's the stuff that gives you direction and help you prioritizing stuff. So what you're looking for is, what problem are you trying to solve? Who's that problem concern? And if you go toward product and product vision, you will need to add the what and the how also. So I get that for now I'm very abstract. So to give you a better example, let me present you the project of one of our clients as an example and as our red line for this talk. So their product was a platform that was helping retailer to source, manage, curate, and provide brand image sequence to website via end-to-end solution. So the retailer don't have any difficulty to manage that. And as for my own problem statement, the data part of it, it's the curation and the sequencing of the image and sequences. For the second layer, or for organizing, this is the reminder to keep the deck clear and the ship log up to date. It's basically to prevent knowledge leak and to better communicate. You need processes, you need documentation, you need tools and methods. So as example, I'm not exhaustive here because there is way too much out there. But requirement, model description, versioning system that help. If you want a much better list, that here you can check the incoming standard for AI, which is the ISO for 42001. And they have a very good checklist again, but a better one, more precise one for all the organization and process and document that you can need in a data science project. So third letter R for relationship. This is a reminder that you're not alone in a boat, that you will have to communicate with people, that your AI system will have to interface with other systems. And also a reminder that being kind tend to help the communication and the interfacing. Here a bit more detail into the AI system that we create for that client. As I told you, we were managing the curation and the sequencing of images. So we took images in the state the brand gave them. We curate them on towards standard. We then use autoencoder to embed them. And we use the embedding and direct sequence of embedding comparison to create sequences of images. And as you can see in that diagram, there is an arrow coming from nowhere and going nowhere. That's not really nowhere, that's the other part of the system. That will be the users, that will be the databases, that will be the brand ingestion component. So for communicating all of that, I will need to discuss with the product manager, the delivery manager, the system architect, the UX lead, and the QA lead. 4-letter T for testing. That's the talk with the QA usually. And that's also flipping the bird to Murphy's laws, basically. So you know that something at some point will go wrong in your system. Sure, it's absolutely certain. So what you do against that is you plan for it. You plan fail-safe, you test before you use it, and you monitor regularly your AI system to be sure everything is still working all right. Again, there is a lot of possible thing here to do. And for good practice, yeah, unit testing, more complete testing, writing test plan, getting usage scenario done. All of that can be helpful. So I know a lot of people are not familiar with the tools that are available there. If you use Python for unit testing, you will probably call the library called the PyTest and unit test. For the versioning tool that will help you get your code up to date, you have GitHub. But Git is the most common one, be it by GitHub, by Bucket, or other tool available. This tool tend to allow plugin for continuous development and continuous integration. There is quite a few talk in PyData during those few days where you will have more information about that. And to create scenario that can be read by everyone in the company, I would suggest you have a look at behavior-driven development, which tend to put they have language which is not fully programmation language, but pseudo-programmation. It kind of put things in order and help communicate. Again, talk with your QA and check the ISO 42,001 fat tend to help. U for usability. So you have created a AI system. What for? How does it fit the problem? Is it interpretable? Is it easy to set up? Is it stable to be used? Is it easy to be modified? All of those consideration is what came into usability. You want your system to be used, so you have to be careful of that, so that other people can use your system and not just you in front of your local computer. Rule of thumb here is to prefer practical over fancy and to keep it simple until you can't. Doesn't mean complex is bad, it means that if you have the choice between simple and complex, simple tend to come with advantage in terms of testing, reliability, and stability. So the example from our red line, choice we have done on considering the usability. You have seen that we create sequences of images. The input for those sequences choice, the guide for those sequences, have been an image guide, and we choose that over a text guide for several reasons. First, because that way we can directly use the embedder, the embedded vector. We don't have to translate that into language. Also because we are completely independent on language that way. We don't need English or French or Spanish or whatever. It's just images. So it came with the inconvenience too. It's not very practical. We can't use directly pre-trained classifier, which rely on language. And that affects the UX and the platform architecture. So to come back with relationship, you have to communicate with the UX lead to see if it's possible and how it's possible to do it with the system architect. We have also done another choice toward usability. Is at first we have split the model into product category. For example, we use one model for the coats and shirts and tops in general, and another one for the shoes. We were able to do that because the model and the metadata were already versioned, so it's not too much extra effort. And because we add the product category as raw data, so it was also quick to access, even if it required a bit of cleaning, but not too bad. And the advantage we get out of it is we have a more accurate result for Bootstrap. So what I mean by Bootstrap by the letter L for life cycle is you have to take into consideration that the data you have available and the data that will be available change over time. So you have to consider the start of the project, where you will have to do with the data you have in hand, and the continuation of the project, where you will have incoming data coming back and improving the model, hopefully. So it's a bit different from the evolution of the project itself, because we are not talking about new feature or new project inside the project. It's really taking into account that the data will change, so your model will have to change too. And as I say, for Bootstrap, we have made the choice of doing some small model, badly trained, but better than random. And for feedback, how we coded that is once the sequence have been given to the end user via the rest of the platform, this user was able to correct or to validate the sequence, and giving that feedback to the embedder, we can group together the images first on making cluster, or we had VQVI. It's basically it's an autoencoder that use vector discrete vector as a base, so we can use that as discrete vector, for example. And that was the feedback loop. And also we had another feedback loop incoming from new images from the brands that we also feed into the embedder. So A, for assessing, the checklist is here to assess what is present. It's not really here to give you order or give you the next thing you have to do. It's there to see what is currently happening. So yeah, from time to time, use it again, take bearings. It's and also plan the next assessment once every time you do an assessment, not to forget the things. And this assessment, it will help you define what you have done well, what you have done not so well, and it will help you define what you need to do next. In agile method, usually you do that sort of assessment every sprint. That's kind of the natural breaking point. And you want to do them regularly, not to be lost. And for the final letter, neatness, when you're assessing one of the parameters we have talked about, the feel you must get is a feel of, the sort of mathematical elegance. There is also other math nerd I know here. So yeah, this one, the feel of efficiency. And if you don't get that feel from what you just have checked, you are probably in front of a risk. To detail a bit more, give a bit more detail into that. Neatness generally don't occur in the project. I think we can all agree to that. And this list, this checklist, it will not tell you what to do, but it will definitely pinpoint what is likely to go very wrong. So if the project vision is not neat, you risk a project abandon because you don't have the general direction. If the usability is not neat, you're probably in front of a design debt. If the testing is not neat, it's probably a tech debt. If the organization is not neat, you're probably facing a knowledge leak risk. And all of that for all the points we have seen before. So yeah, I was a bit quicker than I expected, so there is plenty of time for question or for me to give more detail into something if you want. That's it.
Yeah. Hi, Morgan. My name is Chong. I'm taking over from tomorrow as a moderator. Thank you very much for the very nice talk. I like the analogy that you use in a nautical sense to direct the data science heading. So let's try and see if there's any questions in the chat, and I will just bring them up on screen so that you can answer that. Is that fine? All right. All right. There's the first question here from Just Deep Singh. I'll bring it up on screen so you can see it. Justin is asking, thank you for the presentation, Morgan. Can you talk a little bit more about life cycle?
Yes. So life cycle, when you do a data science project, you usually have data, some sort of model or system AI, and data coming out. The data coming in and the data coming out will vary with time. When you start a project and it happened, for example, with that client, there were plenty of data, but there were no specific order in them, so we had to select a few first and see what happened. And when you do that selection, you don't have access to all the data possible. You only have access to part of the data. For example, they were telling us that they want to add body product at some point, but for now they only had clothes. And instinctively, the model for body product and the model for clothes, because we were both checking the sort of object and the position of the object, is going to be very, very difficult to put in place. So that's why I was, this is not gonna work really. So for now, let's check on one model per product. I know it's doable within the platform, usability. And we will see after that how it will evolve, and hopefully we will be able to gather the model together. But I already know at the start of the project that I don't get all the data yet.
Mhm.
And that often occur. So you have to bootstrap with something. And
Yes.
here it was a model, but as in the talk of Jan yesterday, if your first version is rule-based and if then else, it's a perfectly valid bootstrap too. If it works, it works.
Yeah, absolutely. I like the methodology of KISS, that sometimes is the solution to keep it simple. All right, excellent. Great. Thanks for that very nice answer. For life cycle, I'm looking through a couple of questions. There aren't any just yet, but if I may, I would like to ask one question of my own, since I'm also a data scientist. As a particular tool, which is actually a question that someone has asked as well. So I'll just bring it up by Alejandro. How do you choose what tools to use on which project? Is related to my question.
So I'm in a consulting company. Usually, whatever the client have is the best answer, which means I don't always get to choose. So that's why I'm more focused on processes than tools, because processes can be adapted to different tools, and from the tools you can get the pattern of the process you need to use. So